Hello students, this is Professor Chalai, and in this video we're going to look at naming acids. As always, you can follow along with our Chapter 2 workbook. Now, odds are you've heard of a name of a few different types of acids before. For example, HCl, we all know as hydrochloric acid. And we'll go over how we got to naming these and other acids. But in general, acids are an interesting compound. We'll learn more about acids and bases later in the semester, but acids are interesting because you might think of them as covalent compounds, right? Hydrogen is a nonmetal, even though it's towards the left of the periodic table. Chlorine is towards the right, which means it is a nonmetal. And so two nonmetals, you think this would be a covalent compound. But acids, they break apart into ions, right? The H will break apart into H plus, and the Cl minus, Cl in this case, will break apart into Cl minus. So they're ionic, but they're made up of nonmetals. So acids are a little bit different. And so we're going to learn more about them later in the semester, but for today, we're just going to learn about how do we go about naming them. And we're just going to focus on three different types. First, we're going to focus on binary acids, meaning acids that contain only two elements, and one of those elements is not oxygen. So we just did an example of HCl, two elements, hydrogen and chlorine. None of them are oxygen. Okay, to name these, the rules are simple. We started with hydro. We take the base name of the anion, right? And then we end it with ic, acid. So in this case, we started with hydro. The anion here is chloride. Remember from our previous how to name ions. Chlorine is the base. Chlorine is the atom. We take the base name and end it with IDE, chloride. We take the base name here, chlor, and we end it with ic. So hydrochloric acid. If we had something like HI, right? This would be hydro. It's two elements. So it's hydro. This is iodine. The ion is iodide. The base name is iode. We ended with ic. So it's iodic acid. Hydro, iodine. The base name, ic, acid. Hydroiodic acid. That's it. That's the rule. We start with hydro, base name, ic, acid. All right, so those are for acids with two elements. None of them are oxygen. What about oxyacids? Oxyacids come from all of these ions that we had to memorize that we called oxygen ions from our ion table up here. So these all oxygen ions can also form acids. And when you look at oxygen ions, they typically end in two set of letters. They either end in ate, like ate in carbonate or bicarbonate or nitrate or sulfate or chlorate, or they could end in ite, like nitrite or sulfite or bisulfite or chlorite. Those are really the two types of endings these oxy anions have. And remember, oxy anions are anions negatively charged with oxygen. Okay, so how do we name those two? Well, the rules are pretty much the same. You take the base name of the oxy anion. There's no hydro, right? There are for these acids, we don't include the hydro in them, even though there's going to be a hydrogen. We don't include hydro. We just take the base name of the oxygen ion. If it ends with ate, we replace it with ic. If it ends with ite, we replace it with us, and then acid. Let's take an example. H2SO4. This one's common. This breaks apart into H plus, and there's two of them, and SO4 2 minus. You should have memorized this ion, but it's sulfate. So to name this acid, H2SO4, you probably already know what this is, but how we got that name. There's no hydro. We just take the base name of the anion, sulf, and instead of ate, ate, we ended with ic. So this would be sulfic acid. Now, sulfic doesn't sound as good. This is the only one that's sort of weird, but instead of sulfic, we actually write sulfuric acid. And if we take its partner, let's say H2SO3, This breaks apart into SO3 2 minus and two H pluses. This anion, this oxyanion, is sulfite. Remember, it has one less oxygen, right? So the name is sulfite. So if we wanted to name this acid, it would be sulfur. That's an L. Instead of ITE, we replace it with OUS, sulfurous acid. Those are the three rules. It's hydro-whatever-ic acid, or the base name and either ic or us acid. 3 rules for naming acids. Let's see them in practice. Pause the video, answer number 18, and then you can unpause and I'll select some of these at random to name. Okay, I think I did HCl and HI already. Let's do HBr. This is only 2 elements. None of them are oxygen, so it's hydro. Bromine, the ion is bromide. The base is brom. We add ic, so hydrobromic acid. That's it. Let's try this one. H2S. It's made up of only 2 elements, hydrogen and sulfur. So it's hydro. This is sulfur. The ion is sulfide, right? It breaks up into 2H plus and an S2 minus because sulfur is the third to last group on the periodic table, group 6A. So it has a charge of 2 minus. So it's hydrosulfic and an ic acid. There we go. This one's interesting. We'll come back to that one because I didn't teach you what happens when there's more than 2 elements and it doesn't have oxygen in them. All right, this we talked about. It's sulfuric acid. How about this one? The ions that it breaks apart into is H plus and ClO minus, right? This is hypochlorite. That's the ion. So there we go. Hypochlorite. All right, so what's the name of the acid here? Well, when it's an anion, we don't write hydro. We just take the base name of the anion. So hypochlor is the base name. So hypochlor. Instead of ITE, we replace it with OUS. So this is hypochlorous acid. Let's try one more. This is permanganate, right? From our ion table, right up here. Permanganate. These are some that we need to memorize. All right. Permanganate, where we go? Here we go. Permanganate, H plus, MnO4 minus. It's not made up of 2 elements, so we don't need hydrogen. Hang on, let me write permanganate. All right, so to name this, we do the base name, permangan. Instead of 8, we change it to ic, permanganic acid. All right. This one, let's do this one. It breaks apart into H plus and C2H3O2 minus. This is the acetate ion. So the name is acet, right? ACET. Instead of 8, we change to ic, acetic acid. That's it. This one doesn't follow, it's not quite an oxyanion, but this is H plus and Cn minus. This is a cyanide ion. This one doesn't follow any of the rules. I just threw it in there so that it would confuse you. But this one is, we just call it hydrogen cyanide, in case you were curious. That's why I saved it for last. It didn't follow any of the rules, so you're not really asked to memorize that one. But all of the others, you should be able to name based off of the rules we learned. Okay, try number 19. It asks us for the opposite. It gives us the names of the acid, and now it's asking you to write the formula. Pause the video, try to do them, and then unpause and I'll go over some. Okay, so hydrofluoric acid is one, hydrofluoric, meaning that it's just made up of hydrogen and fluorine. Fluorine is in it's a halogen, so it forms a -1 charge, so we only need one hydrogen and one fluorine. That's hydrofluoric acid. Nitric acid. If we look at the name, we can figure out what ions it comes from. So nitric, the base name is NiTr. Instead of IC, the ion would have been nitrate. And if you look at our table, nitrate ion is NO3 minus, right? Again, one of those that you need to memorize. So to get the acid, we just put enough hydrogen, H plus, to balance out the charge. So this would be HNO3, one H plus to balance the one charge minus charge. Try that with chromic. Let's try carbonic, right? Carbonic, the base name is carbon. If it was ic, it means it came from an ion that was ATE. The carbonate ion, if you look at your table or you've memorized, is CO3 2 minus. So the formula for the acid, to balance out the 2 minus charge, you needed 2 H pluses. So we do H2CO3. That's a carbonic acid formula. Let's do one with OUS. Here we go. Chlorus. The base name, let's choose a different color. Let's do red. Okay, chlorus, the base name is chlor. OUS means that the original ion had ITE in it. Chlorite. What is the chlorite ion? ClO2 minus. Right? This is one that we needed to memorize again. So for the acid, for chlorous acid, we needed one H plus to balance out this one minus charge, so it'd be HClO2. And there it is, the chlorous acid. You can try the others, and if you're struggling with naming, you can still let me know. Otherwise, we'll end the video here, and I'll see you in the next lecture. Goodbye.